This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Happy Thursday to you. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 56. We've got a great presentation today in the spirit of Independence Day. Geostationary Lightning Mapper Observations of Bright Meteors. And our presenter is Randy Longenbaugh, researcher from Sandia National Laboratories in Albuquerque. Our discussion will be facilitated by Linda Gilbert, lead meteorologist at the Weather Forecast Office in Marquette, Michigan. As always, we have a few reminders before we get started that the session is being recorded. There'll be an opportunity for Q&A after the presentation, so please post your questions in the chat and we will field them through there. We are looking for future presenters, so if you have an application you'd like to share with your colleagues, please get in touch with us. And if you're looking for training materials, Brian Mata and his fellow Cooperative Institute staff can field your questions regarding where materials reside. Thanks to the Tower S team, particularly Kashad Bowman, the Office of the Chief Learning Officer, the GOZAR and the JPSS programs for their support. There's a lot of work that goes on behind the scenes to deliver the Satellite Book Club Seminar Series weekly. And thanks to all of you for joining us. Looks like we have another great set of attendees today as we come up about 50 attendees. Without further ado, I'd like to introduce Randy. He is a researcher at Sandia National Laboratories for about 36 years. He has led a team of remote sensing analysts for the past 20, primarily focusing on optical transient luminous events, which include bright meteors called bolides. Recently, Randy left Sandia on a remote assignment to NASA Ames in Mountain View, California to support NASA's Planetary Defense Program. While on assignment, it was discovered that GLM was detecting bolides, and he spent his assignment developing a GLM bolide detection program. So happy 4th of July, and Randy, welcome to the Satellite Book Club.
Thank you. As was said, I'm working at Sandia Laboratories, which is run by the Department of Energy. I was jokingly telling somebody recently that DOE can also represent defenders of the earth, and it kind of is in line with this topic. So I work directly for the Planetary Defense Coordination Office, and I support the work at NASA Ames Research Center, and also the work that's going on at the Space Dynamics Laboratory. And I'm just acknowledging my colleagues here. I'm going to talk about the GLM bright meteor detections and the relevance to the weather forecaster. I'm going to introduce the Planetary Defense Program at NASA and explain why these detections are important to NASA. I'm going to talk about some of the published bright meteor events with space-based observations and also ground observations. I'm going to talk about the work that's going on at NASA, also at NASA Ames, and also directly with the PDCO. A little discussion about the bright meteor detections from GLM, and also a slide or two on the correlation of GLM and the US government meteor events. And there's a slide on some of the interesting detection artifacts that we've seen in our hunt for bolides, and wrap it up with a summary. Now, the relevance to the weather forecaster, this is my opinion, and so maybe I can get some feedback on this, but why should the weather forecaster be aware of these bright meteors that are detected by GLM? Well, the first thing that comes to mind is when these occur over land, people see them, because when GLM sees an event from geostationary orbit, it's fairly significant from a ground perspective. So the public wants to know what's going on, and the weather forecaster could potentially play a role in that. just situational awareness, what's going on with the sensors that are being used by the weather forecaster, and then also better understanding the additional capabilities of what GLM can bring. Potentially participate in observations and the science behind these impacts. Something kind of interesting, but we're using weather radar to track the dark fall of meteorite debris to the ground. And this has been used quite a few times to point to where to go look for meteorites. And then, of course, you know, meteorology is the study of the Earth's atmosphere and the interactions with the Earth's surface, and meteors interact with that environment, producing visible light and shock waves. NASA's Planetary Defense program is at NASA headquarters. It's run by the Planetary Defense Coordination Office, and that was Lindley Johnson as the Planetary Defense Coordination Officer. Their mission, which is a congressionally directed objective, is to find all of the near-Earth asteroids with ground-based and space-based telescopes and determine their orbits and track them. And right now, they're focusing on 140 meter and larger asteroids. They also are developing ways to deflect a potentially hazardous near-Earth asteroid in space years before they would be on an irreversible collision with the Earth. They develop physics models of asteroid entry so they can be used to assess ground hazards. And while there's no known asteroid risk or impact risk right now in the next century, we know from geologic evidence that a large asteroid can be devastating to the Earth. But also keep in mind that 140 meter objects is about the size of a small football field. It can be cause significant damage if it were to hit the Earth, and we've only found about 1/3 of the population. This is leading into the bolide world, but there was a large event back in February of 2013. It's called the Chelyabinsk event. It was a little smaller than 20 meters, but it produced significant local terrestrial damage. So one way of understanding this small asteroid population is to detect them when they hit the Earth's atmosphere, and that's where GLM can play a role. When a small asteroid interacts with the atmosphere, it produces visible light, and it's called a meteor. An extremely bright meteor is called a bolide, or also known as fireballs. The terminology, I've seen a lot of different terminology being used. And it's estimated that a 1 meter diameter small asteroid collides with the Earth about every 2 weeks, while a 4 meter diameter small asteroid hits the Earth roughly once per year. So why are these observations important to NASA? Well, the scientific community wants to keep track of what's hitting the Earth so that they know what kind of population, so they can keep track of the populations of what's hitting the Earth. When a small asteroid disintegrates in the atmosphere, we can learn a lot about its structure, its size, and its mass. These disintegrations can also be used in the development of physics models, which will help the modelers develop, fine-tune their algorithms. And this is an important point. These objects, small asteroids, they're traveling extremely fast, and they can transfer a lot of energy in the atmosphere very quickly, similar to the shock and light produced by a nuclear explosion. And in our political world, you want to have an organization like NASA making statements about that was not a nuclear explosion. that was a natural occurring small asteroid hitting the Earth. And just pointing out, there were the two largest events in our lifetime. Chelyabinsk was a 400 kT kinetic energy release, and the Bering Sea event, which was fairly recent, 2018. It was, of course, these two were not detected by GLM, but the Bering Sea event, the GOES ABI data actually tracked the contrail for that entry, but that was a 50 kT event. And then you compare that to a 15 kT nuclear bomb explosion over Hiroshima. So these can really produce a lot of energy. There are two websites now that if you want to know what space-based sensors are seeing, the first one and the one that's been out there the longest is a JPL website, the Fireball website, and I've got a link here in the briefing. Their detections go back to 1988 until the present. It is a global capability. It is a near real-time capability, but because of the dynamics of the environment, they do not get published in near real time. And they're only publishing the larger events, which are about a meter and larger. As part of my efforts at NASA Ames, my colleagues created a website to publish the GLM bolide observations, and we go back to 2017 to the present. It's not a global capability. As you know, GLM is a near real-time capability, but we do not publish the data in near real-time. And we are actually, we don't have that charter to do a near real-time publishing. We could, but right now we're primarily for scientific discovery. So we do put a lot of effort into vetting the events to make sure that they're bolides. There's many sites out there that you can go to find information on ground-based observations. I've just listed a few here, ones that I go to look for correlations with GLM detections. There's the International Meteor Organization. There's several all-sky camera networks that are operating in CONUS. One of the bigger ones is the Sky Sentinel camera network. Also, NASA has an all-sky camera network too, run by Bill Cook at Marshall Space Flight Center. So now we're going to talk a little bit about the work that is being done at NASA Ames. There's a program there called the Asteroid Threat Assessment Project, and they are integrating bolide detections from GLM into their observational data program. So this effort includes the autonomous detection algorithm development, also a data pipeline and processing effort, data visualization. We're developing candidate vetting tools for GLM. We're also developing light curve reconstruction. Sometimes these meteors are pretty bright and the GLM electronics does interesting things with them. So we're trying to produce the best light curve that we can get from the data. We're doing database and website development, and of course, the daily analysis of the GLM data. I am the GLM bolide event vetter at NASA Ames. I look at every event that's been published. I look at it and make an assessment of it. We get a lot of false positives. Lightning can be very tricky to weed out. So, and I'll get to that in a further slide. But just to note that a light curve is the measurement of a narrow band visible spectrum optical intensity as a function of time that records the disintegration of a small asteroid. I'm also involved in this project. It's called DOTI. GLM is being used in a separate effort to support NASA's Planetary Defense Coordination Office. They're developing an automated bolide reporting system. It would be a fusion of GLM and what they're already using with US government sensor data. Although GLM isn't a global capability, it provides a lower threshold than what the current capabilities have. And also the light curve that's generated by GLM can be publicly shared and the other data cannot. So yeah. So what makes a bolide distinguishable from lightning? We look at the GLM level 2 group data, which includes the luminosity and positional information as a function of time. And we're looking at the group light curve data. We're looking at the light curve structure. We look at the time duration, the integrated energy, and also ground track movement. So I'm just showing you what a bolide looks like and what a typical lightning event may look like in the level 2 group data. So really, sometimes it's hard to distinguish. So we're using GLM data and ABI also, and I'll talk about that in a second. And again, here's an event that's got ground track movement. It's in the middle of a lightning storm. One could argue that this is a bolide because it hit above the clouds, but it would be very tough for me to call this a bolide because it's intermixed with so much lightning activity. So how do we find these? In our pipeline processing of the level 2 data, we're doing all this on the NASA supercomputer called Pleiades, and that's out at NASA Ames. We're developing machine learning algorithms right now. Our original algorithm was more deterministic and filter based, and we learned a lot from it. We have since retired that approach, and now we've got enough bolide observations to train machine learning algorithms, and there's 2 right now that we're evaluating, a random forest and a convolutional neural network. Another interesting algorithm that's fairly simple in what it does, but when we have a stereo detection of a bolide, we can re-navigate the ground tracks until they converge, and in other words, get rid of the parallax errors. And if they converge at a high altitude, that's usually an indication that the event is a bolide. And you can see from the chart at the lower bottom of the slide, the lightning activity is usually below 20 kilometer altitudes, but probably a mean value of 10 kilometers is more likely. But then the bolide is up at almost 90 kilometers, so that's a good indication that it's not lightning. And of course, the light curves are bolide-like, so this is a good candidate for a bolide. So I mentioned earlier that I vet every single candidate bolide, and so we're trying to develop tools to help me do that job. And so we rely heavily on the GLM data itself, and also the ABI cloud imagery in the region of the candidate bolide to see if we can determine whether it's a bolide or not. And if there's an event that's completely isolated, no clouds, no lightning activity, has a good light curve structure to it, those are easy to vet, but often we'll have a very convincing light curve, ground movement, that would be indicative of a bolide, but it's in the middle of a lightning storm. And those are a lot more difficult to make an assessment. Okay, we have a website, as I mentioned earlier. You can go to this website to see data, and we're about roughly a week behind real time. And that's just because the vetting process takes time. So we have a home page, and then there's an event list page, and then you can go down even further to an event detail page. And let's see, you can go to any event and you can download the data and analyze it yourself. You can scrape the data and do a variety of interesting analyses. And also there's a search capability inside of the web site. You can do searches on keywords. For example, as I'm going to show in this, I think in this next slide, when there's a correlated USG event, I could search for just those events. And this is a chart showing the correlated GLM and US government sensor data. Of course, the US government sensor reports, they only report the really large events, and they are broadband detections. They're not narrow like GLM. The US government data does not publish a light curve, but it does publish the date, time, location, altitude, peak brightness, and the velocity components and the total energy. And I'm showing you what an entry looks like out of that JPL website. And this actually is a stale statement. When I generated this briefing in April, we had 56 correlated events. That number has gone up. And anytime there's a US government detection that's in the field of GLM, GLM sees it very, very well. And I've got showing two examples of what the light curves look like for those correlated events. They're very large and very energetic. I'm going to skip this just in the efforts of time, but we can compare altitudes between altitude determinations from GLM and US government, and I was just showing that GLM is seeing a different population than what US government sensor data is seeing. We're seeing primarily higher altitude events, which is very interesting. There's a lot of science behind this. And then in our search for bolides, we've run across some other very interesting observations. GLM sees non-lightning events, bolides, but also rocket body re-entries, near field satellite glints, very near particle glints, terrestrial glints, including large solar arrays, and we see those all the time. There's two in particular, one down in Chile, and then also in Southern California, we see a lot of activity from those solar arrays. And of course, hot pixels. The upper left image is the Chinese Chang'e 5 third stage reentry. This was a huge event. This rocket motor actually did a lap around the moon before it came back and slammed into the Earth. So it was traveling very fast and released a lot of energy when it hit. We can see satellites glinting us. They have to be, that signal has to be modulated, and that usually means that the satellite's spinning, and this shows sort of a ground track of that satellite as it's passing underneath GLM's CCD. And yeah, so that's all I got there. Some interesting GLM detections. The largest event that we've seen so far was an event south of Puerto Rico, and that was in 2019. from the US government data that their assessment of the kinetic energy was 6 kilotons, which makes it a very large detection from GLM. And as you can see, the energy in GLM is almost off the scale. Because of GLM sensitivity, we can actually pick up meteor showers, which is very interesting. The last Leonid meteor shower in November of last year, just to give you a comparison, on an average day, we'll see somewhere between 0 and 6 events per day. In the heat of that meteor shower, we saw over 160 events in one day. So it has the capability to see meteor shower activity. So in summary, the two GLMs, they can detect bright meteors. Their sensitivity allows them to see tens of centimeters to meter-sized asteroids hitting the Earth. It has a limited dynamic range, and so for larger events, we have to. It's challenging to get a light curve out of a large event. The Asteroid Threat Assessment Project is integrating GLM into their observational data program, and GLM is being integrated into NASA's automated bolide reporting system. And then just reiterating why the weather forecaster might be interested in paying attention to this, I've listed that as well. And that's all I've got, and I think I'm on time. Just a list of some of the publications that we've put out so far. The second to the last journal paper has been published, so you can find that one, and that describes in gory detail the pipeline processing and the machine learning approaches that are being done at NASA Ames. So that's all I've got.
Awesome. Thank you so much, Randy. That was a very fascinating presentation. Very interesting for sure. So definitely want to encourage everybody to stay on for additional discussion, and a survey, feedback survey, will be posted in that chat room. So there's a link there. Feel free to go ahead and click that link and fill out any sort of remarks that you might have regarding the presentation. One thing before we move on to discussion is that our next presentation here will be a week from today. So please join us next Thursday, July 8th, where Kevin Thiel from the SBC will discuss some of the summer 2021 hazardous weather testbed activities. So that should be very good discussion as well. And then if you have any sort of questions about the SBC, or for any sort of configuration of satellite products, please contact the TowerS team, Lee Byerly or Kashad Bowman, and then more information can follow in an email from that team. So again, thank you so much. We're already getting some great questions coming in here, so we'll definitely move on to the discussion. One of the earliest submitted questions here was, see here, it says, I understand that the NASA Ames bolide website is for scientific discovery, not necessarily for near real-time bolide impact situational awareness. Is there a near real-time database available to NWS? So Randy, I know that you had talked about that, but is there something available to the NWS that is a little bit more in real time?
So the capability exists, and it's going to require a discussion. If there's interest, it's going to require a discussion between the National Weather Service and NASA. There is a near real-time capability, or can be. The DOTI website or the DOTI program that I was showing you, we have a version of it that's web-based, and it could easily be fielded to allow near real-time discoveries. It doesn't exist today, but it has a lot of potential to happen. We just need to work with the PDCO, and then it could easily happen. So that's my answer.
Okay, great. Thank you so much. The next question here, can you talk more on how the ABI data are used to QC bolide detections with GLM data? And then multiple parts here, which channels, animations, derived cloud products? And then I've got a second follow-up question there, so I'll stop there for that first part.
So it's work in progress, but primarily we want to be able to see clouds, cloud structure, even when the Earth is dark, because a lot of times the bolides will hit on a dark Earth, and we want to be able to see clouds. Right now, if we have an event that's a very minimal event, there's not a lot of light curve structure, and there's lightning activity around, and there's clouds, all those would go against that event being published. But we're trying to look for isolated events where there's no signs of weather. And when there is an event that has a beautiful light curve structure and ground movement, and it's in the middle of a lightning storm, that's still going to get a lot of attention. And sometimes we have to reach out to other sensors to see if there was any correlations. That doesn't happen very frequently, but in compelling cases, we go look. But ABI, right now, we're looking at the geocolor. We're looking at band 2 also. That's another a go-to band for us to look at. When we have a large event that has a shallow entry angle, and it's burning up in the atmosphere, we have found ABI observations of the contrails. And that's a little tricky to, and we've tried different bands, and I can't go into a lot of detail on that, but I could provide some examples of that and what bands we used to find contrails. I hope that answers the question.
Okay, if not, I'm sure that the individuals who submitted the question can follow up in the chat. For the second part of that question, for very large events, can you leverage ABI data as well? 3.9 micron, for example, and other spectral bands.
Like I said, yes, we can. And we're not going to see the actual impact unless you're extremely lucky. But you can see the debris that's from the ablation and the breakup of the body and it disintegrating in the atmosphere. You potentially could see the debris with ABI.
Okay, great, thank you. Okay, so the next submitted question here, how is the height navigation done for the GLM detections?
So, as you know, an observation from GLM, they make an assumption of altitude. And that's, and I don't recall the exact numbers, but let's just say it's a 10-kilometer sphere. It's not that, it's an elliptical Earth, and I don't remember the numbers at the poles versus the equator, but there's an assumption about altitude. So when you have a stereo event, for a bolide event in general, if you look at its ground track, it is, because it's much higher in altitude, it has parallax errors associated with it. You don't know what they are until you have a stereo event. When you can compare an observation from 16 and 17, you can see the difference in their ground tracks because of the altitude assumption. And so what we do is we raise that altitude assumption. We can keep going higher and higher in altitude, recomputing the ground track until those two ground tracks start to overlay. They can't overlay perfectly because there's, the pixel sizes won't allow that, but we in other words, raise the altitude of that altitude assumption until the two ground tracks line up as best they can. And at that altitude, we can make an assessment, how high is that, and make an assessment of whether it's a bolide detection or not. And we're just using, the software that Clem Tellier provided from Lockheed Martin.
Okay, great, thank you. Next question here. We do get occasional questions about sightings. What are the best sites procedures for trying to track these down near real time? So it's kind of talked about already, but kind of a follow-up there.
I can give an example of this. There was a bolide off the east coast of Florida, and there was a weather forecaster in Tampa who made the connection with the Colorado State SLIDR website, and he was publishing the GLM observation within SLIDR. The problem with SLIDR is that it's integrating over 10 minutes, and all you can see is a spot on a map. And so that is something that to me would be the go-to thing to see if GLM saw something. I would go to SLIDR. But if you want to go deeper, and that's what I've been talking about in this briefing, we'd like to actually show you a light curve of the disintegration. That takes a little more effort, and that's what I think we could provide in near real time if this negotiation takes place and there's interest.
Okay, and it looks like a follow-up statement here on this very discussion here. Says here, was thinking it might be useful to have a near real-time bolide report similar to the preliminary SBC storm reports, which could be made available quickly before the later in-person validation. So just another comment there on that ongoing discussion about those real-time reports. So definitely a lot of interest there, a lot of discussion being generated there. Any remarks on that before I move on to the next question there, Randy?
No, it's in starting and building this program, I see the value in what GLM is doing here. And I see the value in providing the data as quickly as possible, just for situational awareness. And we have the capabilities to do it. But to some degree, the NASA Ames group is saying we do this for science. We don't have a real-time mandate. All we need to do is talk out, why we need it. Go to NASA and see if there's some solutions we can provide.
Okay. And then the next question here, have you looked at any bolide detections from the VIIRS day-night band?
No. And I'm going to take a note on that.
Okay. All right. Great. Great question. And then there's a remark in here about some more satellite views on that 2013 event. So thank you very much for sharing that link in there. And then I actually had a question going back to that discussion about the lightning events triggering false positives. Have you noticed any particular types of events that trigger those false positives other than just a lot of lightning? Is there something notable that you're seeing with those types of false positives?
So the first thing we do when we're even in a machine learning approach, we have to sift through the level 2 data, and the first thing we do is we try to cluster the data in time and space. And so it's how the data is clustered initially is what we see a lot of lightning from our clustering algorithm. So I'm of the belief that this is more of a continuing current lightning artifact, and they just manifest, they get found by the clustering algorithm, and then they get thrown into the machine learning algorithm, and sometimes they look like bolides. So It's tough for me to know. I'm not a lightning researcher to know exactly what kinds of lightning we're picking up, but it would be interesting to share some of the false positive detections and work more closely with lightning researchers to help us understand, is there a class of lightning that's being picked up by this clustering algorithm that makes them look like bolides. So to answer the question, I don't really know. We have some suspicions, but I'd like to investigate it further.
Okay, great, thank you. And we're starting to get here to wrapping up the discussion here. One more question, if you don't mind, and then unless there are any more additional discussions, we'll probably go ahead and wrap this up. In terms of receiving reports, there's been a lot of discussion about that. What about folks who might want to, report a possible bolide detection, whether it's a citizen science type initiative, or whether it's somebody who's watching GLM, those websites that you had previously listed in your presentation, does that allow folks the opportunity to be able to report possible bolides?
Absolutely. I haven't looked extensively at those websites, but I don't think I've ever seen somebody throw in there that GLM saw something. And that would be kind of cool if a weather forecaster were to see, or if there were reports of a bolide and they were able to find GLM data to go with it. That would be a really nice publishable artifact to go with, like on the International Meteor Observation Site. That would be a very nice addition to what they're reporting, because it gives them so much information. Those ground observations, people, they have their watches on, and you're like, well, what time of day is it? Where were you looking? A GLM tells you exactly where this, well, within a pixel size, the limitations of the pixel size, but it tells you exactly when it happened and where. So that adds a lot to what they're publishing right now. So absolutely, I would go there and put that information in those. So the American Meteor Society, and the IMO.
Okay, great. Thank you so much. And just one last question here, if we can knock this out right quick, and then I think this is a good opportunity to wrap up here. Was that large event south of Puerto Rico due to larger energy values observed, or possibly due to the better resolution closer to the instrument's nadar?
So the assessment of that event was made by the U.S. government systems. And it's hard for me to answer that question. I believe it was a very large event that was seen by GLM.
All right, great, thank you.
I don't know how to answer the question, yeah.
Okay, all right, great. Okay, do we want to turn it back over to Jordan now for any closing remarks?
Yeah, thank you, Linda, and thank you, Randy, for such a great presentation, insightful, a little outside of what we normally cover here in the Satellite Book Club, but I know that our weather forecast offices receive calls for anything in the sky. So hopefully this is helpful to some of the support that they provide to the communities. So thank you so much. We continue the Satellite Book Club every Thursday. So next Thursday, July 8th at 12 noon, Kevin Thiel from the Storm Prediction Center will discuss the summer 2021 hazardous weather testbed activities. And in the meantime, if you need to contact the Tower S team, they can address any questions you have about the Satellite Book Club or related to the configuration of satellite products in AWIPS. Look for an email next week on the Satellite Book Club seminar series continuing. For those of you that are off this weekend, please have a restful Independence Day. And for those of you that are working shift, thank you so much. With that, we will call it a day and hope you'll join us next week. Thanks, everybody.